Hey everyone, Mr. Allen here. I was asked to do a better job of explaining this question from the first test in preparation, I guess, for the second test where you have a chance to rewrite a similar question. So I'm just going to go through kind of point by point and see if I can maybe explain kind of what you should be reading when you see that, or what you should be learning or knowing when you see that. So limit as x approaches 1, f at x equals 3. So keys here, first one is to understand that, of course, f at x equaling 3 means that the y value will be 3. So the limit as x approaches 1, it has a y value of 3. If we look on our graph then, as I approach the x value of 1 from both sides, I should be getting a y value of 3. The only time a limit exists is if we approach the same y value from both sides. So in this case, I'm approaching a y value of 3 from the left, a y value of 3 from the right. That's what that first line says. There's no real interpretation there. That is what a limit is. Second one here, f at 1 equals k. So when I put an x value of 1 in, I get some answer k, where k is not a 3. So essentially that's telling me that I cannot have a filled in circle at that spot right there. So I just sort of picked one up here, meaning that there is a value that exists. Any value at all other than this one would be fine for the second part here. And of course that's what I wrote here. That means there is a point 1 comma k anywhere but 3. K is just some variable, just like every other variable you've ever seen. It represents any value, except in this case, not the value 3. Continuing on here, limit as x approaches negative 4 from the negative side, so from the left, I should be getting a value of 0. So that says that basically I need to be heading towards the point negative 4, 0. And I could be coming down this way, I could be coming straight out this way. I would caution you against drawing that one because it's kind of hard to see. The other possibility, of course, is my graph could be kind of sinusoidal and just kind of going up and down, up and down, up and down, but approaching that value from the left. So the way you want to think about these, in case we haven't said it before, is as I'm walking along the edge of the graph, so if I'm a tiny ant or something walking on the graph, I should be headed towards the point negative 4, 0 here. As I approach negative 4 from the negative side, from the left, I should be getting towards a y value of 0. And of course that's what's happening right here. Follow along this line to that point. Or again, it could have been a line coming down this way. Straight line, curved line, doesn't matter. All I know is I have to follow this line and approach that point. Number 4 here. The limit as x approaches negative 4 does not exist. So basically that's telling me that I cannot have a limit, an overall limit, at x approaching negative 4. And just sort of the opposite of what we said here, by definition, if the limit exists, it means we approach the same point from both sides. If by definition the limit does not exist, this means we can't approach the same point from the left and from the right. Well, we had to approach this point, 0, from the left, so we should be able to approach any other point from the right. And again, basically that just means that this section of the line here, kind of leading to an x value of negative 4, can't go to the 0. It can go up towards any of these points. It could come down towards any of these points, just not towards the 0 itself. Continuing on, x negative 4, y is 6, so this is just a point. F at x equaling a value, so this tells me that the point negative 4, 6 must be on my graph. And that's what I've got right here. This next section, as we said from before, simply the only rule was that it could not approach that spot there. So I could have had a graph that looked like this and kind of came out this way. It could have been way up here, just so long as the right side, or from the right side, my limit did not approach that same 0 down here, because we were trying to avoid having the overall limit at -4 existing. Let's see, f at 5 does not exist, so of course that just tells me that I can't have a point at 5. In this case, I have in this section I have a hole at 5, and then eventually with some of the other information I ended up with an asymptote. So let's see what the other information is. The limit as x approaches 5 from the left, so as I'm approaching 5 from the left, I'm approaching a value. So basically, again, I have a variable here. A variable represents any number. So basically this is saying I am approaching some number. From the left, I am approaching a number. In this case, I happen to choose the number 1, 2, 3, or 5, it looks like. But again, I could have chosen any other number as well. I could have just as easily approached something up here. And then the limit as x approaches 5 from the positive side does not exist. Okay, so again, not quite the same as last time. Last time the overall limit does not exist, which simply meant that from the two sides I cannot approach the same value. In this case, the limit from the right does not exist, so I can't approach any value. Well, from functions, we know that the time when that occurs, our graphs don't just end, our graphs kind of slide down along an asymptote. And so essentially what this is saying is I have an asymptote down here. Last one, x must exist for all values other than 5. So x does not equal 5 is the domain. That means that 5.000000000001 must exist. We can't have holes in the graph. This is saying that every single x value in our entire graph other than 5, we have to have a point. And so my graph is continuous to this point. Then there's a point at -4 as well. Good. Continuing on. Oh, wait, I got a hole. Oh no, but it's continuous up here. Up to this point, 5 is allowed to not exist. And then from there, of course, I have to have values, which means that I must have had an asymptote at that point. And after that, of course, the graph can go off and do whatever it needs to. There is nothing in here that says what goes on from x being 6, 7, 8, and so on, so I just kind of let it head off in that direction. Could have done all kinds of things. Could have been something like, again, sinusoidal at that point, just kind of continuing on. That would be fine. All we know is it has to exist for every single value other than x equal 5. And just going to erase this now. Now the reason I wanted to erase that is to make sure you all recognize our graph cannot have multiple y values for an x. Everything we work with is a function. We follow advanced functions with calculus. Calculus is done on a function. And so every one of these must have a single value for y for any value of x. That is to say, as soon as you start trying to put multiple values in here or multiple lines in here, you're breaking the fact that our graph must be a graph of a function. So hopefully that helps explain a little bit. Again, each of these in itself should be pretty easily understood. Certainly in here there was a little bit of thinking required, but most of these should have been fine. If you have questions still following that, anything I didn't cover or explain well enough, please feel free to ask them. Probably just easier if you've had some sort of explanation to go from, because it seems like maybe some of the little notes here still weren't quite clear to everyone.